Good morning. I hope you can all hear us out there. This webinar today will be in English, so I hope that's okay. The first 2 slides will actually be in Danish, but I will speak English. So just so you know. First of all, we are very sad that we actually cancelled the last webinar with Robert and Jeppe due to some sickness. The new date is actually already sent out, and it will be October 3rd. So I hope that everyone out there can actually participate in that date. Today we will actually show a platform demo with Mohamed and Jacob. They will get the chance to actually introduce themselves later on. As most of you know, or some of you know, I'm Christopher, and I'm a customer manager in Globe team. As last time and the other times we have had this webinar, it's possible to actually ask questions in the Q&A. And please do it through the whole webinar. I will look at the questions and maybe stop Mohamed and Jacob through the webinar to actually talk about the questions. Otherwise, we will end the webinar 9:50. So we actually have 10 minutes to do questions there.
Sounds good.
I'll just keep focus.
So yeah, and as you know, all our knowledge is not only us 3 here in the room. We're actually a business with 180 consultants doing all from security to infrastructure and to network design and so on. And then the newest thing, and the thing that we are focused on a lot these days, is also our new managed service with 24/7 support. That's actually who we are. And with that, I've been asked to actually do this quickly due to all the nice things that we're actually going to show today.
Time is ticking.
Time is ticking. So now I'll just actually send it over to Mohamed and Jacob.
And thanks very much, and welcome also. I think just in terms of introductions, Mo, you are sort of the ones that hadn't been in the former webinars. Perhaps if you could say a little bit about yourself.
Absolutely. So I am Mohamed El Gindi. Basically, the reason that we're doing the webinar this time in English is for me. So thanks a lot, guys. Really appreciate it. I've been in Denmark for about 2 years now. I am a sort of a DevOps platform engineer, cloud architect type thing. And I used to do a lot of public cloud before, and now I'm more focused on on-prem and private cloud platform engineering. And the main reason for that is actually because, well, on-prem doesn't suck anymore.
No, we've also mentioned some of the former webinars that private cloud is coming back with a vengeance, and a lot of people are asking for hybrid cloud at this point, right?
Yeah, exactly. It used to be all about, you know, having one big hypervisor running virtual machines that are managed as pets by manual administrators, and this is all, of course, in one big open network.
Yeah.
And well, I'm here to show you that this is not really the case anymore. That is now a thing of the past.
Yeah, and that being said, of course, we also do a lot of public cloud implementations depending on the needs of the customer, right? So it typically ends up with most of our customers having a number of public cloud installations and at least one private cloud installation.
Yeah.
Yeah. Cool. Was that you?
Yeah.
Cool.
So.
And for the ones of you that's already been participating in some of the other webinars, you know a little bit about my background. Otherwise, I encourage you to see the videos that have been put out there of the former webinars. But in terms of this, I've been working with Mo on several engagements now, primarily concerning open source private cloud installations, right?
Okay.
And we've been both creating platforms together, and we've been creating teams together.
And fooling around, of course.
And fooling around a lot. But Mo is also, when he's not doing or implementing the actual platforms, you also very often take the role as a technical trainer or sort of playing while building and training while building. So we've built teams together also.
Exactly. Yeah.
Yeah, that's
fail early, fail fast.
Exactly. That's what we do. So I won't spend a lot of time on these sort of introduction slides. I know that you have come here for the demo, not for the slides. But just to give you an idea what we're going through, I'll give you a brief session. The former webinars also talked about specific private clouds and so on. Also about some of the issues with the public cloud versus private cloud and so on. But just to give you an idea, why is it that we are talking about private cloud specifically today? We are big fans of public cloud, but there are some scenarios and some use cases that calls for on-premise engagement still.
Yeah.
So private cloud versus public cloud, and also I'll introduce the actual the one that we've chosen for this demo, which is one technology. So we're doing all the demos today based on one technology, one private cloud technology that is open source. Mm-hmm. And then we'll head into the demo land, basically. Yeah. Cool. Good. So as I said, remember that we have a lot of information, also sort of some of the more both technical, but also on the change management side. How do you actually build teams? How do you actually build an organization around it on the former webinar? So please have a look at those. But why do the companies that we engage with ask for private cloud? Why is it that we don't just hear, hey, we've got everything for free, we don't want to sort of maintain our own private infrastructure, let's just go all in on public cloud. So just not that we are sort of trying to sell private cloud at all. We don't really have any preferences, but very often the customers that are asking for this.
If it's a cloud, I'm happy.
Yeah, exactly, right. and of course we could go into a lot of definition work about what that is.
Yeah.
But what we're seeing here, and remember some of the warnings from the former webinars, that the initial investment in private cloud is larger than in public cloud. It's easier to get started public cloud, but overall cost, what we're seeing is that there are, for the most common use cases, it is actually over time cheaper to go build a team that sort of maintains a full private cloud and have the options of typically 1 to 3 public cloud offerings.
That's of course a sort of a general trend, but I mean, if you're very good at optimizing your workloads in public cloud, and then in private cloud you're also inefficiently managing a huge team of administrators and data center personnel, then of course in situations like these you'd also have things tipping over on the other side.
The reality of things is that we are still seeing that at least 90% of the larger companies' application base is VM based at this point. So it also makes sense not just to put 1,000 VMs into public cloud and paying by the hour.
Exactly.
That is more expensive typically, even with purchasing reservations and so on. Okay, so typically people are going for compliance and control. There is something to be said about. I just heard yesterday the CEO of Microsoft Denmark stating basically that GDPR is making it difficult for everybody, and it is making it difficult for the American vendors, which are the top 3 public cloud vendors, incidentally, right? So at least there's an argument still to be made, and is being made daily about the fact that if you can keep your data and your whole infrastructure on Danish ground, at least for a normal auditor, you typically have an easier time. So we're not saying that that's the only way to go. We're just saying that you have to argue why it is safe to put EU data into the public cloud still. Yeah, that's just how it is.
Also, just to add one more point to that, it's also important that it is said that that doesn't necessarily reflect also security. Because sometimes people see, I guess, compliance, control, and security as the same thing, but public cloud is actually very mature in security. However, some of the EU compliance rules and the company compliance rules don't exactly align with what's actually being done on public cloud.
There's nothing wrong with public cloud. Security is often better than what you can build yourself. But the implementations that then happen in public cloud then creates all the insecurities, right? Yeah. So, But also, of course, if you're a Danish company on Danish ground, or just a Scandinavian company, for instance, and you don't have a footprint across the globe, of course, you'll also gain the benefits of being very close. Your users will be very close to the data center, and therefore high speed, low latency.
Yeah.
I think we see a lot of people also going for the ability to customize. That can be done anywhere, but it is easier to pick and choose, especially for the open source private clouds.
Yeah.
And I think also that a fun argument that we'll get into later is also that if you look at how often do you see releases, you actually see releases to these open source platforms, the popular ones, not the not so popular ones, but the popular ones are released even faster than what you see in public cloud at this point. But of course, that is basically the truth of any software product. If it's widely popular, it also gets more funding and it gets more releases typically.
Yeah.
Cool. Yeah, we've said this, right? Beware the initial investment into private cloud.
It is a medium to long-term sort of return, right?
Yeah. We can build a private cloud for you in a day, but you won't get any benefit out of it immediately, and it takes time and it takes investment to actually get it to something that you can use for something. When I say we can build, I mean this guy. So
you.
Yeah. So open source, we've chosen to do the setup today on a little bit. There's a little bit of a mix involved, but the base technology here is OpenStack. Mm-hmm. OpenStack is, as it says, it's the second most popular open source project that's out there. I think the most popular one being the Linux kernel.
Yeah, exactly.
But apart from that, it's really used by a lot of people. But in Denmark, it's relatively unknown. There are some companies using it, typically the C25 companies, and also a few governmental setups that are using OpenStack. Yeah. So it's arriving in Denmark at this point, but otherwise I think like 70% of usage is American at this point. Yeah. But it's really some fun and cool technology. You can really pull things down from the shelf, and that basically also is one of the big advantages of OpenStack. There are, at this point, we don't know exactly, but we know that there's more than 4 million hours poured into voluntary work about OpenStack. So that basically means that when someone sees something that's cool on AWS or Google or
let's bring that over.
Let's bring that over. So you get a lot of voluntary content that you can then pull down from the shelf.
Yeah, and just to add to that, the real power of open source is that it can grow exponentially when it's becoming popular, right?
Exactly. Yeah.
So the more people are using it, the more demand for features, the more contributors there are, the more mature it becomes faster, the more security implementations and sort of work that is put into it, and so forth. And then you can basically grow in a way where lots of contributors are just happily sort of aligning and working together into building something big.
Yeah, and of course we know that decision makers, when they hear open source, they might pause a little bit. Is that safe? Do we know what actually is inside of the code? And it is a good idea to be a little bit wary. We do know that OpenStack is being used by some pretty big and well-known companies like Blizzard, for instance.
Yeah.
But I think in terms of our understanding or our sort of knowledge about security, one thing that we do know that we put some weight in is that the American Defense Cyber Unit uses OpenStack.
Yeah.
That doesn't necessarily mean that if they find some weaknesses that they would actually publish it. Yeah. But since 70% of the users are American, we're pretty sure that if they catch something, they'll catch it before we do and fix it. Right?
But actually, also just to sort of build on that point, Good security is not going to be affected by people actually seeing the code or not.
No.
On the contrary, if people are able to see the code, they're actually able to contribute and detect any security vulnerabilities early on.
Yeah.
This is also controversial, a lot of contradictory, of how people think open source is, right?
Yeah.
Also, Bitcoin is open source.
Yeah, it is. Yeah, but again, that doesn't necessarily mean that there's a lot of trust and good feelings about that, right? So we do understand that decision makers might want to drift towards more supported solutions. We see a lot of implementation in Scandinavia of OpenShift as a container platform, for instance, simply because it's supported by Red Hat /IBM, right?
Yeah.
So we've mentioned that in the former webinars also.
Mm-hmm.
OpenStack comes with a lot of functionality. So basically, it comes with a lot of core infrastructure, like VMs, like containers out of the box. You see all the main component network as a service, storage as a service, all the things that you would expect from a public cloud vendor. And the reason why you basically choose as an infrastructure interested guy, you choose cloud, right?
Yeah.
You get all that from a private cloud just as well, and just as using basically the same things that are running in public cloud. Not exactly the same things, but some of them, of course, proprietary to Microsoft, for instance.
Yeah, exactly. Very good multi-tenancy, and also apart from infrastructure as a service, there's also PaaS services that are offered there.
Exactly. You see things that get offered, like hosted database services that sort of complement that, but you can do your own hosting of the most popular open source databases that comes with the territory.
Yeah.
Basically, pull down, install, plug and play, more or less. And the same goes for a lot of things that helps the application owners and the application developers. All they need in terms of key vaults and load balancers, all the things that you would like to have as a developer.
Yeah.
So you get all that just as you would in public cloud, with one exception, right? And that one exception, of course, being hyperscaling. You only have the hardware that you have on premise, and you'll always be limited by that. And unfortunately, some use cases we see actually leans a little bit against that. If you're going for a machine learning setup and you want a lot of calculations done very briefly, it might be a better idea to sort of scale that out, that calculation itself, scale that out to public cloud and really churn it with a lot of GPUs very fast, and then get the result back, instead of trying to build an entire GPU-based on-prem setup. But we also see that, the last one. And then just to mention about, there are real differences between the private cloud offerings. Make sure that your private cloud can actually work when the internet is not available or the vendor is down, because we have seen that. It shouldn't happen, but it does happen. So in terms of stability and making sure that everything is available, make sure that you choose private cloud vendors that actually can run in Ireland.
Yeah.
OpenStack is one of those.
That's also a quick comparison with the private cloud offerings / products of the big three.
Yeah.
Right.
So, which are typically trying to sort of be a stepstone towards public cloud.
Public cloud, yeah.
And some of them, at least, for instance, the Microsoft Azure Stack HCI, basically needs contact with the mothership at least every 30 days in terms of licenses and so on. Doesn't mean it necessarily will break, but it's not a reliable.
It's not built for
no. We haven't seen Azure being down for 30 days though, so you might say it's a small risk, right? But still, yeah. So often, when saying, well, why would I choose this from a CFO standpoint? OpenStack is free. All the 4 million hours poured into this is free, but typically you end up in having a relation with companies like Canonical, Mirantis, in terms of making sure that even if your own local people are not available, are not able to do something, you want a support set up. So you get this supported by a third party. It's not a lot of money for a really big setup. We had, I think it was around like 30,000 euros per year.
Yeah.
And that was the entire cost for the entire platform, except for the initial investment in people, of course, and the team and salaries. So that's OpenStack for you. We're not selling OpenStack because we can't, it's open source. So we just chose this as something that we are familiar with, and we've done some installations based on OpenStack, and it's a really healthy and well-supported product, right? So what are we going to see today? We are going around the world doing a lot of things. I don't know, do you want to say a little bit about what you'll show us today?
Well, I guess the goal right now is for us to start considering specific use cases that companies actually go through from different sort of personas, different experience levels, working in different parts of the stack.
Yeah. So basically, what we're doing today is not just showing you, we're going to do 4 demos, right? And I can see that there might be a question coming in.
Yeah, and let's take the question before the demo.
Yeah.
It's just a simple one. Sorry. Do you have any statistic, or do you know anything about cyber hacker attack on open source versus well-known vendor solutions? I think well-known vendor solutions would be Microsoft.
Yeah. Okay. So quick answer: no. We don't have statistics to say that one is more or less secure than others. The problem here being, of course, that not all the people that have been hit have what we have in Denmark, for instance. They're not forced to report any of these. So you will only find fluent numbers in terms of statistics, no matter where you search. But you can find some sources about it. The American cybercrime unit, for instance, publish some numbers on this. It's very America-oriented, which of course means that you have to look to multiple sources. But in general, just a word of warning: we have seen companies, serious, well-established companies, coming up with statements like, no, we don't use antivirus because it's running Ubuntu. So basically believing the threat picture is only towards the most popular things like Windows-based setups and so on, which is of course utterly untrue, and of course you shouldn't get lax on security just because it's not the most wanted threat picture. So in general, what we're seeing is that the well-established used most in the bigger companies, the software like standard Windows, standard Microsoft offerings, and so on. It's more hours are put into protecting it, but more hours are also put into attacking it.
Yeah.
So there is actually a balance there, but don't trust either the most well-founded to take care of your security, and don't trust the fact that it's not a big threat picture either. In general, you are in charge of security. You need to make sure that your platform offerings are secure by default and compliant by default. And there's really no coming around it. The most security threats and vulnerabilities we've seen are human-made. They're human-made by the ones implementing, not the ones actually offering the service.
Yeah. Automation is the answer.
Yeah, make sure that people cannot make mistakes.
Yeah.
That's one of the things that we're going to show you today.
Perfect.
I hope that was sort of a valid answer.
I think so.
Cool.
All right.
So yeah, as you said, we are going to try some a little bit different today. We are instead of just showing you technical demos, we are going to try to show you a little bit how we work. Mm-hmm. So typically how we work is we build the foundation of a platform, and we have dialogue with of course the company. Also, typically we are building a team at the company we are at, so they will of course also own a lot of the dialogue with their colleagues, and then you'll be approached by some sort of need from some sort of branch of the company that you have to answer as a platform engineer with your platform. And that's basically what we'll try to emulate here. We'll try to, from 4 different angles, present something to you that makes sense to different personas, you might say, in the company.
Yeah.
But we'll do a how to deploy a VM via GUI, how to deploy a VM via the embedded CLI in OpenStack. We'll also, just make sure that you don't think that we are suddenly lovers of VMs. We do see a lot of VMs in our application picture, but we actually do, when possible, we typically recommend that at least new stuff be built on containers. So we'll also show a container. I think building the whole container setup will probably take more than we actually have today, but at least to show the
just initiate things.
Yeah, and then we'll end up with a full stack.
Yeah.
So let's try to do it that way, Mo. I'll try to be one of the personas, and you give me an idea how you would approach that if you got that notion.
Yeah. Just so you know, the clock is ticking.
Yeah.
So we're probably going to have to talk at 1.25 speed.
Okay, cool. But that's really easy because it's you from here. I'll now be a traditional admin in an IT setup. I'd like to deploy a VM like I do perhaps in Azure, so that I can hand it over to the database or application teams I work for. How would you offer something to me?
So typically, you want to build everything as APIs, right? But to cater for the current needs, you also want to have a front end that makes the API calls. It's typically just a light GUI or whatever to just do what needs to be done for the specific personas. In this case, I actually don't need to create a GUI because OpenStack already ships with a GUI, actually 2. One is a little bit more legacy, cloud legacy. Of course, we're not comparing to real legacy, but the other one is more modern, Skyline project. Also open source project that we're going to be using to deliver the VM. Just a quick note, you'll also see that OpenStack is pretty mature with network isolation. So just like you would have in Azure or in public cloud, a resource group where you can create VNets that is completely isolated from other VNets. We're actually going to also be able to create secure VMs that are both sort of macro and micro segmented. That is going to be secure by default.
Yep.
Cool. So time for me to switch over. Let's see. This is the OpenStack GUI. Again, all I needed to do was deploy this as part of OpenStack. And I am here in my project space. You can already see that this looks somewhat familiar to what you see in the public cloud vendors portal. One thing that you typically don't see in the public cloud dashboards is this stuff here, which is basically quotas. Remember, with private cloud, you also need to solve a problem that you typically don't have in public cloud, which is the fact that you have finite resources, right? So, so to avoid a situation where a single project or a single tenant is using all the physical hardware resources available in the cloud, you typically set quotas on a project so that they're basically capped at how much resources that they can use. Again, a project is an isolated space to create cloud resources, private cloud resources, that is going to be completely separate from a different project. So on the left side here, I'm not going to go through this, I don't have too much time. You also have lots of the sort of as a service offerings, storage, networking, and then you also have file shares, databases, and container orchestration. So as a GUI administrator, I would go to compute, instances. I already have 2 instances. Let me create more. So I would go to Nova specification. I choose the flavor, which is basically a t-shirt size of the resources that we want to allocate. Let's go for M1 medium. Let's see, I want to create a Ubuntu server, system disk. I can allocate 40 gigabytes. Next, we go into network configurations. I'm going to deploy it in DemoNet. Moving forward, do I want a security group, which is basically firewalling that happens on the interface level? I can always view the rules. So you can see here, things are secure typically by default. You also have, for example, things that you might see like ingress any, but don't be fooled. This is actually only from other security groups with the same ID. So this is only within the micro-segmented network that if you have a virtual machine within the same network, it can communicate with a virtual machine unrestrictedly by default. Anything coming externally is blocked, except if it's SSH over here, and if it's ping, or if it's one of the following ports. So I am just going to go for default. Next, name, test, VM, key pair. I'm going to put in my SSH key. I'm going to get a kind of summary of my setup, and I should be able to just confirm. And just like that, I am creating a VM. So I guess let's avoid the waiting time between the creation of resources and just move on.
Yeah,
to the next use case.
that's probably a good idea in the interest of time, right?
Yeah.
But I think what people saw here was the fact that since the microsegmentation is not optional, you're creating your applications and so on inside somewhere where you know how the application actually wants.
Yeah.
And that means that you also need to have a dialogue with, sometimes it's a dialogue about my application is not working because it's being blocked on this and that port. Mm-hmm. But you still need a dialogue with people about the application, how it works, so that you set it up so only the traffic that's needed for the application to work gets through, nothing else. Yeah. And that's microsegmentation and security by default at a glance, right?
Exactly. And just one final point regarding that. So typically in the sort of on-prem world, you have like different VLANs that the data center team or the sort of the operators or administrators are managing themselves, right? Mm-hmm. And then they have like one big like database VLAN, they have one big app VLAN, they have one big DMZ exposed app VLAN, and so forth, and they're protecting all the different VLANs with firewalls.
Yeah, they're doing perimeter basically defense around those, right? Yeah, exactly. And hope that one node in there doesn't get hit.
Exactly.
Yeah. So, but it does, as Maersk will tell you.
Exactly. So again, just to kind of get a visual on what's actually going on in terms of the setup, we have one exposed network that has been configured, the EXT network, and that then connects to virtual routers, and then those virtual routers have virtual networks and subnets connected to them. Yes. Again, we have full control of everything. This is I'm creating this VM in a completely isolated space that typically no one would have access to unless I specifically allow access. Yeah.
And there are lots of things to be said about best ways to set up a network. We want also to have network as code and so on. But let's avoid that subject today, since we are a little bit pressed in terms of time.
Yeah. So that's basically. Does that answer your use case?
Yeah, that's exactly what I needed as an admin. That's used to operating from GUIs. And basically don't know a lot of development.
Yeah.
Yeah. Okay, but let's move on then. Then now I'm someone else. Mm-hmm. I have a familiarity with PowerShell. I do most of my my administration still manually, but by running scripts mostly.
Yeah. Okay.
So I like scripts.
So that's like the next step. You're scripting and automating, but still not using declarative infrastructure as code.
I'm still a human hitting something. I'm just doing it via the command line interface, or sort of. I do most of my work in a prompt.
Yeah.
Yeah.
Okay. This is the definition of a system administrator.
Oh, really?
Sysadmin. Yeah.
Okay.
This is the exact persona. So for that, I would basically get right into interacting with the CLI. Let's create some resources and see where that takes me. So now I'm in sort of terminal mode. I know you make fun of me for the size font 4.
Never. I would never do that.
Okay, so I hope this is good enough. Let's grab a fresh window here. So OpenStack, of course, comes with CLI, API, and a GUI, and of course, infrastructure as code tools that we'll see later on. So right now, I'm going to be interacting with the CLI.
And by the way, while we say CLI a lot, command line interface, right?
Yeah.
For people who aren't, like 3-letter abbreviations.
Yeah. So I installed the OpenStack client command line interface tool, and now I'm going to be creating a VM. So OpenStack server list, I can see the VMs that are already deployed. I can then create a VM, but first let me have a quick look on the flavors available. OpenStack flavor list. Again,
so flavors basically are predefined sizes of VM that has, a number of CPUs, a number of, and so on, and might be configured differently also, right?
Exactly. Let's also see networks available in terms of the virtual networks. I have already pre-created a few. So I want to create a VM on DemoNet of size M1 small. With the Ubuntu image, so let's also have a look at the images available. Of course, that could have just as easily been a Windows image with a GUI that I either console into with the sort of the mouse, or I can even remote desktop connect.
Yeah. Typically, either the platform teams or some other team maintains at least one Windows-based and one
Linux-based.
Yeah, Linux-based.
Typically Ubuntu.
Typically Ubuntu.
Yeah. So let me create that VM, OpenStack server create image. Let me grab the Jammy image, network demo net, and let's say flavor M1 small. Test VM CLI.
And the team from Canonical, they send us small stickers every time we mention Ubuntu. It's
just little smileys.
Make them a little bit more happy every time.
So just like that, with a single command, I was able to initiate the creation of a virtual machine. If I do OpenStack server list, I should be able to see it now in my list of VMs. This is the one, and we can see it's already active.
Okay.
Of course, if we really want to, can always also view it from here. We can go to compute instances. We'll see the VM over here. And just to show you that console is available, I can do something like that. Of course, as a tech-savvy person, I'm probably not going to be leaning into that. Probably going to be doing more of SSH and so forth.
Yeah. So what you just did there was basically using the interface to connect directly to the VM that you had just created.
Yeah. Exactly.
Cool. So we also it actually exists.
Yeah. Exactly.
That's a good demo, right?
Yeah.
Cool. Anything other than that? It's basically the same as before when it comes to all the security by default. Everything is done the same way, basically.
Yeah.
It's just been protected, and you still need to choose the same things. And you might implement a level of parsing and so on to make sure that you can't do something wrong in terms of naming and so on.
Yeah, exactly.
So that either comes on top, crossing all the platforms. You typically have more than one, right? This is just one platform.
Yeah.
But you might sort of this is like directly towards the platform.
Yeah, you might create like another layer on top that basically parses and so forth, and all your sort of interactions go through that.
Yeah.
Or you can even modify the current OpenStack layer by actually going to the platform. It is all open source after all.
So people don't just create servers that are called Motest 01 or something like that, right?
Exactly.
Cool. So now I'm a DevOps, or even myself. I might be myself being a platform engineer, or working with one of the DevOps engineers. We are used to doing everything in code. But I work, or I'm the middleman between an application team, and I would like to them deliver on an app that is using primarily Kubernetes containers. I would like to present them with basically Kubernetes functionality.
Yeah.
How would you go about that task?
So OpenStack actually ships with a open source project or service called Magnum, which is container orchestration as a service. And Magnum is able to deploy vanilla Kubernetes clusters that actually ties into with cloud providers to your OpenStack cluster, even including single sign-on and the volume service and the load balancer service and so forth. It also includes file share and object storage. And typically, I would just use APIs to deploy this Magnum cluster. However, we've seen from Denmark already that typically the ones that are already at that level don't want to take full responsibility and management of the health of the cluster.
No. Right?
What we've seen, that people have preferences for vendor-supported container platforms. So far, the most popular one I've seen is OpenShift.
Yeah.
So actually, OpenShift is an open source project. Of course, we pay for the enterprise support, just like as we would with the other open source projects, including OpenStack. So even Red Hat has their own OpenStack and OpenShift, and they have automation of deployment of OpenShift on OpenStack.
Yeah. So if you don't want to, you don't have to interact with Red Hat and IBM. They are actually offering it out for free as open source.
Exactly. Yeah. So I'm just gonna start that one up. Of course, it's gonna take a little bit longer, and we don't have too much time to actually wait for it.
No, I'm actually thinking that if you're going to build an entire cluster and so on, we might have to jump to the fourth one while it builds.
Yeah.
But perhaps we can.
So I have so the OpenShift without the enterprise support is actually called OKD, which is the pure open source version of OpenShift. Mm-hmm. So I'm going to be using OKD. It's practically the same thing. I mean, the tool itself is called OpenShift install, and with that I can just run the automation, and it's even a little bit interactive, so that I can show that I'm actually doing something and not everything is pre-created and set up beforehand. Mm-hmm. So shift stack, external network, I want to connect to the public one. It's already pulling resources from OpenStack and giving me a choice of how I want to set things up. So it's telling me the flavor. Let's go for M1X large, base domain, okd.local. Let's say okd local. And pull secret. This is OKD pull secret. I'm gonna do a cheating sort of move that I do, which is basically grab things very, very, very quickly from Google. This is the one that I want, which is a fake pull secret URL. There we go.
So what is being built now?
So now the OpenShift installer is interacting with OpenStack directly to run Terraform under the hood, to create virtual machines in the base image of a Red Hat base image, mm-hmm. and it's able to deploy OpenShift on those VMs. It also interacts with OpenStack to create the load balancers and all the needed resources.
Yeah, and the ones seeing the first two demos saw that you chose some, the size of the in this case the containers. You chose networks and so on. how is that defined in this case?
So with the installer, it actually just creates all the resources beforehand. So you're actually, it's expected that there's very little prerequisites. However, you can do a sort of a more customized installer or installation with current existing resources if you need to.
Yeah. If you wanted to, for instance, call your pods or your whole setup, if the containers need a specific name, for instance, where would you specify that?
So there is a massive config.yaml generated as part of the installation process. Typically, if you don't want to specify that, all the defaults are populated. But then after you generate the configurations, you can always go in and modify them.
Yeah. So in this case, we're using YAML files. It could be stated in another declarative setup, like JSON files or something like that. But in general, that is how you answer the same questions as you did in the GUI and the CLI. You basically fill out either while you do it or beforehand. You fill out the YAML or JSON files to support either Terraform, Ansible, the chosen language of the company or the chosen tool of the company.
Yeah.
Yeah. And I guess you could, on top of those files, you could still do parsing and make sure that everything was compliant by default and so on, right?
Yeah, of course. So all the tools are there and everything is possible with automation, right? So you can always build on, especially with open source, you have ability to actually modify the source code, or you have an ability to know exactly what the source code is and you build a layer on top of that that overlays on the original functionality.
Exactly. Yeah. And you can specify things like landing zones, where do you generally want this to happen? What should sort of be the other areas that this particular setup should be able to contact and so on inside of that.
Yeah.
Yeah.
Cool. So yeah, with that you just run the OpenShift installer and then you have a running OpenShift cluster. Very little work required from the platform engineer to actually get that set up. Cool.
Good. So in this case, we were container based, but as I said, 95% of our sort of application base, 90 to 95 when we start out in most places is VM based still.
Yeah.
So let's return to VMs, but now I am an application developer.
Yeah.
I don't like my IT department. I don't like to talk to them. I want to have, my application is VM based, but I want to be able to do everything.
Exactly.
Without any middlemen. I want to do it at 3 o'clock in the morning if I get a good idea. I want to have full control, but I still don't want to make big mistakes in terms of security and compliance.
Yeah.
How would you approach?
And just to clarify, including or excluding a 3-week waiting time to get a single VM?
Yeah, I want it 24/7 and I want it now. That's basically it, right?
Okay.
And I want to do it quite often because this might actually be embedded into my own pipelines.
Yeah.
So I might, for instance, do a test of my own software when I check in code, and I want to deploy hardware, do a test, export the results, and destroy hardware.
Yeah.
How would you do that?
Okay. So of course, especially if it ties into like different environments, if you have like test environment, development environment, or multiple development environments for different people, or each team member has their own development environment and so forth. Mm-hmm. Right. So this is really the bridge that that a lot of companies are actually aspiring to do, which is still having things as VM workloads, but actually treating the VMs as cattle, which is the new way. Everything is infrastructure as code, and it's not either you have like these massive, slow-moving pet VMs, or straight into container world where everything is already transformed and is in microservices, right? Mm-hmm. So there's always that balance that that a lot of enterprises are actually finding it very difficult to achieve. So for that example, I have I would develop a Terraform script. Well, it is not exactly a script, but I would develop in Terraform. I would ensure that all the resources are deterministic and are declarative, so that I can replicate my environment whenever I want, wherever I want. Oopsie. So let's go back here. Switch windows to this one. I already have my Terraform set up in this directory over here, so I'm just going to apply it. Terraform apply, what to approve.
And what is actually being built here? It's not just the infrastructure beneath it, right?
So what is being built at this moment, and you're going to see a better graphical representation of what's actually going on, but we are building a highly available application, 3-tier application, with 3 replicas of a front end, 3 replicas of a back end, and 3 replicas of a database. And this is all load balanced with an OpenStack load balancer.
Yeah. So how many VMs are we talking about?
This is
just one database?
6 VMs.
6 VMs.
3 application VMs. They're hosting both the front end and the back end, and 3 database VMs.
Okay. So redundant database setup, redundant application setup, all being deployed in one go.
Exactly. So if we do OpenStack serverless, now we should see that we have app 1, app 2, app 3. Those 3 applications are done. We have DB1, DB2, and DB3. They're going to be getting set up. How are we doing on time, Christopher?
We have 2-3 minutes.
2-3 minutes. Okay. So I can also see if I do OpenStack load balancer list, I can see that my load balancer is active. If I do OpenStack floating IP list and I grep for this IP, again, a floating IP is basically a NATed IP on the network level. I use floating IPs to expose my applications to the rest of the world. Yeah. Because by default, it is protected.
So people using or going to your application would go to, of course, a DNS resolved address, but they would basically hit your load balancer that would then distribute the load to the working servers, or even distribute load if there were a lot of load on those.
Yeah, and you can see here the application is still getting started up.
And all the components here are basically off-the-shelf things that we haven't built ourselves. It's basically just pulled down from the OpenStack list, right?
Yeah.
Other people have built this for us.
So you can see here, probably going to need a couple more minutes to get set up. I'm not quite sure we have the time to actually wait. But this setup is redundant, I promise.
Yeah, fair enough.
Believe me.
But I think people get the idea here, right?
Yeah.
If this was, part of a daily or even more than one daily happening for a developer, there wouldn't need to be a dev to ops talk. There wouldn't be a talk with operations and so on. It would be part of what's going on every day. It could run every morning, for instance, before the developers meet into work to make sure that their setup is functional and working. It could be used for all sorts of testing purposes and so on and so forth.
Exactly.
And of course, the art form of creating the good YAML files that actually support this perfectly, and the back and forth between the development and the platform team, which are...
That should be the real manual work, right?
Exactly, and those people actually speak the same language, so exactly. the IT to application team is typically much easier and much faster.
Yeah, exactly.
Cool.
So I think we're good here. Yeah, it looks like it just needs a couple more seconds, minutes, but I don't think we have the time to wait.
No. But still, people can see from the demo that the items are getting created. Thanks for that. Good demo.
Oh, it is. It just got created.
There?
Yeah, it just got created.
Up and running.
Yeah.
Cool. Good to see.
Sounds good. So
I think I'll sort of skip the recap. This is what you've seen today. You've seen a little bit of how we actually work in the companies that we engage with. And that's basically what the main purpose of what we wanted to show you guys today. Yeah. We know that a lot of our participants of these webinars today are actually joining the computer world thing.
AI conference.
So we're not expecting a lot of questions today. I must admit. I don't know if there are.
We have no questions yet. We have 5 minutes left. So please just ask questions. I think we have time for 1 or 2.
Yeah. But otherwise, please remember that if you are watching this on video after the fact, which we of course understand, we probably would have too, feel free to reach out to us with questions, even small and relatively just interested small things. Also, if you have comments, things that you want to share, we do have one more webinar and one more perhaps.
We have a seminar?
Yeah, we have a seminar. We just don't know exactly how and when. But we're doing a physical seminar where we also might be able to see each other physically. That would be nice, right?
Yeah. And there are still no questions. So let's skip that part. Yeah, I think we will just say thank you very much for today. Remember that with the QR code here on the side, you can actually go and see a lot of other courses and a lot of other webinars in there as well. And then thank you for your participation and thank you for today. Thank you, you guys.
Thank you.
Thank you for today.
Well done, Mo. Thank you.
Well done, Jacob.
See you guys.
Have a nice day. Bye.
Bye.